All right, let's kick things off with a little experiment. You don't have to do anything complicated, just watch the screen. You ready?
Okay, I want you to focus your eyes right in the middle of the screen. Try not to follow the dot, just stare at the center.
And here we go.
Keep looking right at the center.
And again.
So what did you see? It looks like it's moving, doesn't it? Like a single dot just zipping back and forth across the screen.
But here's the crazy part. It didn't. Nope, not at all. There was no actual movement on the screen. What you were really seeing were two completely separate dots, one on the left, one on the right, just flashing on and off, one after the other. That feeling of motion, that was created entirely inside your brain.
So, what in the world is going on here? Well, what you just experienced is a really powerful optical illusion. And yeah, it has a name.
It's called the phi phenomenon, and what it is basically your brain taking a shortcut. When it sees two things pop up near each other, one right after the other, it just assumes it's easier for one thing to have moved. It says, hey, one object moving makes way more sense than two separate things just appearing out of nowhere. So your brain just fills in the blank and poof, you see motion that isn't really there. Now you might think this is just a cool little party trick for your eyes, the basis for movies and animation, and it is. But it's also so much more. This simple illusion, it literally sparked a revolution. It completely turned our understanding of the human mind on its head.
To really get why this was such a big deal, you gotta look at what was happening in psychology at the time. Back in the late 1800s, the big idea was something called structuralism. Think of it like this. Psychologists believed you could understand the mind by breaking it down into the tiniest little pieces, like atoms of experience, the basic sensory bits. Then, in 1912, Max Wertheimer comes along with this simple dot experiment, and suddenly, that whole idea just didn't work anymore. See, when Wertheimer asked people what they saw, they didn't just say, I saw a dot here, then a dot there. They said they saw movement. He described it as objectless motion. It was just movement itself that existed in the empty space between the dots. And this was a massive problem for structuralism. I mean, if you're just adding up the parts, dot 1 plus dot 2, where does the movement come from? It wasn't actually on the screen.
And right there, that simple little illusion kicked off this huge debate about how we actually see the world. Are we just building up our reality piece by piece, or is something else going on?
This really gets to the heart of the conflict. The old school structuralism would say the whole is just the sum of its parts. You see dot 1, then you see dot 2. End of story. But Gestalt psychology, the new school that grew right out of this experiment, said, no, the whole is something else entirely. It argued that our brains aren't just passive cameras recording everything. They're active artists, constantly organizing all that sensory data into meaningful patterns, into a whole picture, a gestalt. The movement you saw wasn't a part, it was the whole that your brain created.
Okay, so if our brain is the one calling the shots and organizing everything we see, how does it do it? Are there rules? You bet there are. And this is where Gestalt psychology started to get really interesting and practical.
The Gestalt folks figured out a bunch of these mental shortcuts our brains use all the time. For example, there's proximity. We automatically group things together if they're close to each other. And closure, which is super cool. That's why your brain can see a complete circle even if it's just a bunch of dashes. Your mind literally fills in the gaps for you. What all these principles show is that our perception has a built-in bias. It wants to see simple, complete, whole patterns.
But hold on. The story gets even weirder. Just when you think you've got this phi phenomenon figured out, scientists found another version of it, one that seems to mess with the very fabric of time.
This one's called the color phi phenomenon. Get ready for this. Imagine a red dot flashes on the left. It vanishes. Then a blue dot flashes on the right. So what do people see? It's absolutely wild. They report seeing one single dot that smoothly travels from left to right, and get this, it changes color from red to blue about halfway through its imaginary trip.
Okay, just let that sink in for a second. How is that even possible? For your brain to show you the dot changing color in the middle of its path, it would have to know what color the second dot was going to be before the second dot even showed up. It's a total paradox. It's like your brain can see into the future, right? Well, here's the mind-bending answer. It doesn't predict the future. It edits the past. This quote here nails it. Our brain doesn't create our conscious experience in real time, second by second. Instead, it kind of waits a fraction of a second, it collects all the data, it waits for that blue dot to appear, and then it constructs the most logical story of what happened. It goes back and retrospectively creates the perception of a smooth motion and a color change. So what you're consciously experiencing isn't a live feed of reality. It's more like a slightly delayed director's cut. And that just leaves us with this incredible, profound final question, doesn't it? This whole thing started with a simple illusion, but it peeled back the curtain on a fundamental truth. Our minds are not just passive mirrors reflecting the world. They're incredible storytellers, actively building our reality from all the little bits and pieces of sensory information. So if your brain is literally constructing something as basic as motion and color, what else is it constructing? What about our memories, our emotions, our entire sense of who we are? What other parts of our reality are we building without even realizing it?